All right, this is Algebra 1, Homework 1-5. We've got mixture word problems. In general, every single one of these problems is going to be solved with the same type of equation, which I will write up here. So we'll say, in general, your formula is going to look like this. We'll have amount 1 times a percent, or it could be a cost 1, plus amount 2 times the percent 2. All of this will be divided by the two amounts added together. So amount 1 plus the amount 2. What will happen here, this will give us our final percent. Again, this percent, this percent, this percent can all be turned into money signs and it still works. So I'm going to be referring to this formula over and over throughout this entire homework. Here we go. I have 8 liters of a 5% sugar solution was mixed with 2 liters of pure water. And that means pure water is 0% sugar. What is the concentration of the mixture? So I'm looking for the final concentration of the mixture in these two parts. So I'm looking for this piece. So I don't know that. I'm going to go ahead and label that X over here. And then on the left-hand side, I have the amounts. I have amount 1, which is 8 liters, times its percent. I'm just going to say 5%. A lot of people think that you need to convert this into a decimal, but you don't need to. They'll cancel out. And then I'm going to add this with the second amount, which is 12. I'm going to multiply it by its percent sugar. It doesn't say any percent sugar in here. It's pure water. It's 0% sugar. So it's kind of a tricky question, but it's 0% sugar. And this is all going to be divided by the two amounts added together. Again, our amounts are usually out front if we did it correctly. This amount and this amount, this amount, this amount. The percentages are not used in the bottom down here. So I'm going to bring 8 and 12 into the bottom, say 8 plus 12, and then I solve. Well, this is already solved for x, which is kind of nice. 8 times 5 is 40. 12 times 0 is 0, so it's 40 plus 0, all divided by 20, which is 40 divided by 20, which is just 2. So each of these are equal to x, equaling x. So the concentration of the mixture, this is a percent question. The answer here is going to be 2%. So in general, every single time that you answer a question, you'll get an X down here, and then you'll interpret the answer and box the interpretation. So sometimes you'll have, maybe the answer was 2 liters, but it wasn't because it was talking about a concentration, aka a percentage. What about number 2? Kind of the same setup, it looks like. We're finding the total cost of the mixture. So we're finding the final cost, or the final percent. Not percent, but cost. So I'm switching all these for dollar symbol, dollar symbol, dollar symbol. So we're looking for the final. So I'm going to say the final we're looking for is x. I'm going to have some sort of fraction set up over here. So on the top, I have 7 ounces of, that costs 4 per ounce. So I'm going to say the quantity of 7 times 4 plus the next quantity, 14, that costs 1. So 14 times 1. 14 times 1. All this is going to be divided by the two amounts added, so 7 and 14 are the amounts added, which is a fancy way of saying that these are being brought down here. 7 plus 14. And I just need to simplify this. It's already solved for x over here, so the x is still solved for. 7 times 4 is 28, plus 14 times 1 is 14. All of this is going to be divided by 7 plus 14, which is 21. 28 plus 14 is 42, divided by 21. That's equal to x. And I read it out of room, so I'm just going to do it up here. I'm going to say that's 2 is equal to x. Okay, so that is our answer. We're not going to box this, though. We need to interpret our answer. To what? This is going to be $2 per ounce, because we're asked for the cost per ounce. The cost per ounce, right? So I'm going to go ahead and box $2 per ounce. What I should be doing on each of these is checking my work as well. So the first one should be 2%. And we got it right, so 2%. The next one is $2 per ounce. So whenever you're checking your work, you're going to be highlighting your answers in green or purple if you made a mistake. So that one's green, that one's green. We're good, all right. And number 3, how many pounds? So every single time I see the words how many, I usually just do this. I cross it off, and I change this to x. So it's x pounds of cane molasses, and that's $2 per pound, must be added with 7 pounds of beet molasses. So I think my variables here are going to be C for cane molasses and B for beet molasses, which costs $4 per pound, to make the premium molasses, which costs for the final, this is the final amount, this guy's final. The final cost is 3. So in this case, we don't know the final cost, or we do know the final cost, sorry. So we do know that right side. We don't know the left side, the setup. So let's go ahead and do that. We're going to do cane molasses. So it's going to be x times 2, because it's quantity, number of pounds, times the price per pound. So it's going to be x times 2 plus the next 2 being multiplied. So it's going to be beet molasses. Beet molasses is 4, and how many pounds of that one? Oh, it's 7 pounds of beet molasses, right? So 7 times 4. 7 times 4. And this is all going to be divided by the total amount. So we have this amount and we have this amount. Those are the two amounts that are going to be coming down here. And again, they're usually the first two numbers if you're filling in the formula perfectly. So it's going to be x plus 7. So we have our formula set up. I'm going to go ahead and erase this so it gives us some more room and move this up here. So let's go ahead and solve. I'm going to multiply 2 times x to get 2x. I'm going to add this with 7 times 4, which is 28. And this is all going to be divided by, unfortunately, it's still x plus 7, and that's still equal to 3. So in general, whenever you have a fraction, you're trying to get rid of the fraction. So I need to get rid of this pesky x plus 7. So to get rid of divide by x plus 7, I do the inverse operation, and I multiply by x plus 7. So over here, I'm going to say x plus 7. I'm going to be multiplying the entire left-hand side is being multiplied by x plus 7. The entire right-hand side is going to be multiplied by x plus 7. When I do that, this x plus 7, this x plus 7 cancel out, leaving me with just a 2x plus 28. And that's going to be equal to, and I can distribute here. So 3 times x plus 7 is 3x, and 3 times 7 is 21. So I've now boiled down this gross fraction-y equation into a simple equation that I can solve it from the very beginning of Algebra 1, right? Let's get rid of this 2x by subtracting 2x on both sides. So we'll say minus 2x on the left, minus 2x on the right, leaving me with 28 is equal to 1x, which is just x, plus 21. Then from here, I'm going to subtract 21 on both sides, subtract 21 on both sides, and that's going to give me x equaling 7. So we have an answer. Many people want to box that answer. That's incorrect. You need to interpret that answer. Is that a price? Is it pounds? Is it price per pound? We're asking for how many pounds. So our answer is going to be pounds. We're going to bring pounds down here, and we're going to say this is 7 pounds, LBS. And what we should be doing is checking our answer, 7 pounds. So I'm going to come down here, and we're going to highlight that one green. I got that one right. All right. Number 4, how much? Okay, every time I see the words how much, I'm going to cross it off and say that that's x. X amount of soil times 40% do you need to add with 2 cubic yards of 46% clay in order to make the final amount of 44% clay. So this is the final amount because we're making that. We're making the final 44%. So over here on the right-hand side, I'm going to say that this is going to be equal to 44%. This is maybe needs to be moved right here. And I'm going to have a fraction over here on the left. That fraction is x of 40. X amount times 40%. So x amount times 40% plus, and then over here I'm going to have 2 amount, so 2 times the 46. 2 times the 46. And then all of this is going to be divided by the 2 amounts. I have x amount, it's going to come down here, and I have the 2 amount, which is also going to come down here. So it's going to be x plus 2, and hopefully by now you've started to see the pattern. This one always comes down here, this one always comes down here. And very similar to the last equation, we need to get rid of this pesky x plus 2. In the last equation, we got rid of the x plus 7 by multiplying by x plus 7. In the same way, we're going to get rid of the x plus 2 by multiplying by x plus 2 on both sides. So I think I need a little bit more room, so I'm going to move you up here. And I'm going to say multiply this by x plus 2 on the entire right-hand side, x plus 2 on the entire left and right-hand side. I said that this was right, but that's to the left. What will happen is this term and this term will cancel out, leaving you with just the 40x plus 92. How do I get 92? 2 times 46 is 92. This is going to be equal to, and I'm going to distribute. 44 times x is 44x. 44 times 2 is 88. And I'm going to solve. So I'm going to, let's get the x's all on the same side. I'm going to subtract 40x subtract 40x. That's going to leave me with 92 is equal to 4x plus 88. From here, I'm going to get rid of the 88, or move the 88 to the other side by subtracting 88 on both sides. Leave me with a 4x is equal to a 4. And final step here, we are going to divide both sides by 4 to get x is equal to 1. So interpret the question. What were we trying to find? We're trying to find an amount of soil. Amounts are in cubic yards, or you can say that this is yards cubed, but usually people say cubic yards. So we have 1 cubic yard, or yards cubed. Let's go ahead and check our answer. 1 cubic yards, 1 cubic yards. All right, so we got that one correct. We're going to highlight that one in green. Number 5, we got some mixing metals. So she created a final metal, and the final metal contained 50% iron. And she made this final metal by combining 2 other metals. So we know that the final amount is 50, so I can come down here and create my final amount. Say the final amount is 50. I don't know what the left-hand side of the fraction is going to be. Ooh, that fraction is a little bit too long. There we go. So what were the 2 amounts? One metal weighed 2 and was 20%. So I'm going to multiply these together. The amount was 2, and I'm going to multiply this by 20%. And the other one weighed 6 kilograms, but we don't know the percent. It's the what percent. So when I see the word what, I'm going to cross it off and change that to an x. Then x percent of it was iron. So we're going to have 6 kilograms of what percent? Of x percent, right? And then on the bottom, I'm going to do the 2 amounts added. So we have 2 kilograms and 6 kilograms. Those are going to be moved down here. So I'm going to say that I have 2 kilograms plus 6 kilograms, and then I just need to solve. So I'm going to go ahead and simplify a little bit. I'm going to say that this is 40 plus 6x, all divided by 8, is equal to 50. Very similar to the last 2 problems, I had a pesky x plus 7. So in this problem, I have a pesky 8. To get rid of the x plus 7, we undid the division by x plus 7 and multiplied by x plus 7. To undo this division by 8, we're going to multiply both sides by 8. So I'm going to come up here and say multiply by 8 on the entire left-hand side, multiply by 8 on the entire right-hand side. What should happen is the 8 and 8 should cross-cancel, leaving you with a 40 plus 6x on the left-hand side, and on the right-hand side, 50 times 8, I'm not sure, but 8 times 5 is 40. Add on the extra 0. 40 is 400. From here, we just solve. So I'm going to subtract 40 on both sides because I already have the x is already isolated on one side. So this is the side for x, which means the right side is for the constants. All right, minus 40, and I'm getting 6x is equal to 360. Final step is to divide by 6, and I get x is equal to 60. How did I know that? 36 divided by 6 is 6. Adding on the 0 gives you 60. Okay, we have our answer. Let's interpret the answer. What were we looking for? Was it an amount? Was it kilograms? No, it was a what percent. So this percent is going to come down here, and we're going to say 60% for our final answer, which we will then box. Checking our answers, 60% for number 5. Excellent. We can go ahead and highlight that one in green. Number 2, very similar. We have 2 quarts of a saline solution, and that's being mixed. So that's one of the 2 components. So let's go ahead and make our fraction. We're going to say that this is equal to the final solution. What's the final solution? It says 47% is the saline solution that we're trying to make. We're making the final. So 47% is going to come down here. We're going to say that this is 47. And then what are we mixing together? We have 2 quarts of a saline solution. And we don't know the percent for that one, but I'm just going to leave it there for now. So 2 times some percent that I will fill in later, plus 3 quarts of 65%. So usually you always do an amount multiplied by the percent. So I'm going to say 3 times 65. And that made a 47% saline solution. And now it's saying, okay, find the percent of the concentration of the first solution. So the first solution that we didn't know the percentage that we have right here, that's going to be our x. And I'm going to have the 2 amounts. This amount comes down here. This amount comes down here. We're going to add those together for a total amount, 2 plus 3. And then we need to solve. I'm going to go ahead and simplify first. When I simplify, I get 2x plus, let's see, 3 times 65. Well, 3 times 5 is a 15. I'm carrying the 1 on my finger. 3 times 6 is 18, plus the 1 on my finger is 19, so 195. All divided by 2 plus 3 is 5. It's going to be equal to 47. All right, I've simplified a little bit. I need to undo this division by 5 to make this not a fraction. That means I'm going to multiply both sides by 5. When I do that, what should happen is 5 and 5 should cross cancel, leaving me with 2x plus 195 will be equal to 47 times 5. How do I do that? Well, 7 times 5 is 35. I'm holding the 3 on my fingers, and I'm saying 4 times 5 now is 20, plus 3 on my fingers is 23. All right, and then I need to solve. The x's have already been isolated. I just need to get rid of this 195, and I think I'm ready to go. So let's go ahead and subtract 195. Let's do that in a different color, though. Subtract 195 from both sides. Subtract 195 from both sides. Leaving me with a 2x on the left, and on the right-hand side, that's going to be 40. Finally, divide both sides by 2, divide by 2, and you get x is equal to 20. Now we need to interpret that number. We were looking for percent. So my answer is going to be a percent. It's going to be 20%, which I will then box the interpretation. 20%. Did we get it right? 20% for number 6. So I'm going to highlight that one in green. Not eraser, but highlight. There we go. Number 7 and 8 are notoriously difficult. So I don't even know if I'll be able to fit them all the way in here. I highly recommend using a second piece of paper or writing these on the back of the homework. There's plenty of room on the back because it's only used up a little bit of space for our solutions. For number 7, we have some fruit salad, and it costs $8 per ounce. So that's my final amount is fruit, because I'm doing peaches and bananas to make the fruit salad. The fruit is the final amount. So what I need to do is say that that is my final amount. I'm going to say something, 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 something is equal to 8. 8 is my final answer when I mix them. Okay, I'm going to have some amounts multiplied by prices. So I'm going to make some variables here. I thought I was going to make variables in one, but this time I'm finally making variables. I'm going to make a variable P and a variable B. One for peaches, one for bananas. I think I'm going to have 2 different variables in this one. So peaches cost $10 per ounce. So I don't know the amount of peaches, but I know it's going to be multiplied by 10. And I don't know the amount of bananas, but they cost 4. And they make 9 ounces of fruit salad, but I don't know how many ounces of each. I don't know the quantities that go here and here, which means I need to leave those blank or variables. So I'm going to call P for peach. Remember, peaches are worth 10, so P goes with the 10. So I'm going to put a P here. And then I don't know bananas that cost 4, so I'm going to say B times 4. I'm going to put a B down here, B times 4. The total amount is going to be these 2 quantities added. P and B are going to get P plus B get added down here. And my equation is done. There's a problem with this equation, though. The problem is I have a P and a B. I have 2 different types of variables in one equation. There's one equal to sign, which means I need a second equation. If you have 2 variables that are not the same, you need 2 equations. So let's make a second equation. We haven't used the fact that we have 9 ounces of fruit salad anywhere in this equation. That must be where the second equation comes from. If I add the 2 quantities together, if I do the quantity P and I add the quantity B, that adds up to the final amount of 9 ounces. So check this out. If P plus B is equal to 9, this P plus B must be 9 as well. So I can rewrite this equation. I'm going to leave the top blank for now because I know that the bottom is going to be rewritten as 9. The right side is going to be equal to 8 still. I need to figure out what to do up here because I still have 2 different variables, P and a B, which is a problem. So is there a way that I could manipulate this equation to isolate a P or a B? And the answer is yes. It doesn't matter which one you do because you need to find both of them. So it says find the number of ounces of peaches and bananas. So you have to find both of them. It doesn't matter which one you isolate for. I'm just going to subtract B on both sides. I'm going to isolate the P. Subtract B, and P is equal to 9 minus B. So what I'm saying here is that if P is equal to 9 minus B, this P is also equal to 9 minus B. That's called substitution, which means 9 minus B is being plugged in to P. I'm going to, instead of writing P here, I'm going to write 9 minus B. And that entire quantity P, this entire quantity P, is being multiplied by 10. So I'm going to say multiplied by 10. And then I'm going to rewrite the rest of this, plus B times 4, which is 4B. and check out what I have now. I've combined this equation with this equation, and I have now one equation, because there's one equal to sign. And how many different types of variables? I have a b and a b. That's the same type of variable. I only have one type of variable. I'm ready to solve. I'm going to solve this in very much the same way that I was solving the last one. I'm going to get rid of this 9 first by multiplying both sides by 9. Multiply this side by 9 as well. And what will happen is the 9 and 9 will cross cancel, leaving me with this top piece on the left-hand side. This top piece, I'm going to do some things to it. I'm going to do this 10 and I'm going to distribute it. So I'm going to show my work and say this 10 is going to be multiplied by the 9. 10 times 9 is 90. And this 10 is going to be multiplied by negative b, giving us a negative 10b. I still have to write everything else out. I have to have a 4b. And over here on the right-hand side, I'm going to multiply 8 times 9 to get 72. Excellent. And this is much easier to solve. I'm going to go ahead and combine my like terms. I have a negative 10b and a positive 4b, making a negative 6b. So now I have 90 minus 6b is equal to 72. I know that my 6's and b's look different, but sometimes ours look the same. My 6 is slightly curvy and my b is nice and straight. The left-hand side already has a variable, so let's go ahead and move the non-variable, aka the constant, to the right-hand side. The way that we do that is we subtract 90 on both sides, subtract 90 on both sides, and I have a negative 6b. Please remember, the negative still stays behind, is equal to a negative 18. From here, I'm going to divide by negative 6, divide by negative 6 to get my b isolated. I ran out of room, so I'm going to say that b is equal to a negative divided by a negative is a positive, and 18 divided by 6 is 3, so b is equal to 3. While that's nice, I'm not done, because I know that there are 3 ounces of bananas. B was for bananas. There are 3 ounces of bananas. What about peaches? I have never solved for peaches. I can use this p or this p. Either equation will work. I'm going to use this p. So to do that, I'm going to say, okay, b is 3. If this number here is 3, 3 plus what gives you 9? Well, 3 plus 6 gives you 9, so I can just come down here and say p is equal to 9. P is equal to 9. So we have our answer. Again, people want to usually box that, but no, you need to interpret that answer. So we're going to say this. 3 ounces of bananas. I don't know why I did an M there. And we have, did I write a 9 there? Mr. Sindel, I said 6, but my hand wrote a 9. I apologize. This is 6. And we have 6 ounces of peaches. And we're going to box our interpretation. Let's go ahead and check our work. 3 and 6. 3 of bananas, 6 of peaches. We got it right. Notice that the answer in the back also interprets it. So I'm going to highlight everything here in green. I want to do that slightly better. There we go. All right, we're on to number 8. 8 is going to be very similar to number 7, where I'm going to need 2 equations to solve. Let's go a little bit faster this time. So in number 8, we have brand A and B down here. Brand A and brand B, and that's going to combine to make brand X. So brand X, the final percentage is 42. The final percentage is 42, so I'm going to say 42 belongs to the right-hand side. I'm going to set up a fraction over here. In this fraction, I don't think I need that much space. There we go. A little bit up. Yeah, right there. Okay. What are the 2 amounts? A is 22%. You can already figure out that they're not telling you an amount for A. So I'm just going to say A times 22. A times 22. Well, that concludes 5th period. My prep period is over. I'll record in the lunch for you guys. And I'm going to add together the B amount, which I don't know, by the percent that B is. It says that brand B is 61%. So 61% is going to come over here. 61%. And I'm going to get the 2 amounts added together. Again, you always usually do the first term here, this third term here, and you're going to say A plus B. So our first equation is set up. The problem, again, is I have 2 different types of variables and 1 equation, which means I need 2 equations. So is there some information that I haven't used? I got the 42, I got the 22, I got the 61. I have not used the 39. So the 39 is going to make our second equation. If I add the 2 quantities together, I should get 39 kilograms. So if I say A plus B I add them together, I should get 39 kilograms, which means this A plus B is this A plus B, and that A plus B is 39. 39 is going to be plugged in for that denominator. I'm going to rewrite this and say the fraction is going to be equal to 42 still, but the denominator is now 39. I still have something times 22, and I still am going to add something times 61. The question is, which one of these are we going to rewrite? Because I'm doing how much of each, I have to figure out both of them. It doesn't matter. Let's just move the B over here. I could have moved the A over here. Here, sure. Let's do it. Let's move the A over there. It doesn't really matter. Let's say minus A. That means B is going to be equal to 39 minus A. It doesn't matter which one you isolate. If we isolate B, we're good to go. So if this B is 39 minus A, then this B is also 39 minus A. So 39 minus A is going to be plugged in for this B. In this spot right here, I'm going to write 39 minus A. So in parentheses, 39 minus A. Someone is knocking on my door, but I'm right in the middle of the recording. I'm going to ignore them. Sorry, person at the door. If I have an A right here, this is also an A. I'm just going to keep bringing it down. This A and this A are the same, which means I have one type of variable and one equation I'm ready to solve. So finally, I'm going to do some more math and try to undo this divide by 39. The way that we undo divide by 39 is by multiplying both sides by 39. Multiply the left side by 39, multiply the right side by 39. When I do that, the 39 on the left will cancel out, leaving me with, let's see, 22 times A is 22A. If I distribute, I should have 61 times 39. Ooh, that's a hard problem to do in my head. That's very close to 40 minus 1 times 60 plus 1. 4 times 6 is 24. Add the two zeros. I have a minimum day. That's what's going on.